Today we're working with the line of best fit. So we're taking a line of best fit and then we're using it to make some predictions about the data that's been given to us. So line of best fit is when a scatter plot has a linear relationship, so we can see that it's either going up or going down in the linear fashion, and then we can draw a line that is best description of how the points compare to one another. So this line of best fit is not perfect, and that's why it's called a best fit. It should lie as close to possible to the majority of the data in the scatter plot. So a lot of times when you look at a line of best fit, it almost will cut your data in half. So half will be above, half will be below. So when we look at this, we have written equations of lines, and you're going to need that information for what we're doing today. So this says step number one, again, these should not be unfamiliar to you. Step number one is to find B by using the y-intercept of the line of best fit. The key here is we're just looking at our line of best fit. We're not worried about all of the other data points because sometimes our line of best fit won't hit any data points. We're looking at what is the equation of the line that has been drawn. Forget about all the points. What is the equation of the line that's been drawn? So for example, when I look at this one down here, my y-intercept or my starting point is this right here, which is at 8. So my B would be a plus 8. It then says, once I found that, I'm going to choose my 2 points for the line of best fit, only my line of best fit, and find the rate of change. This is my rise over run. So rise, my y's are on top. Since it's a line of best fit, it may not hit any of the graphed points or our scatter plot points. So we're just going to use what we know about the equation of a line to write that. So then you're going to use our answers from steps 1 and 2 to replace our M and our B, just like we've been doing. Okay, so I already have 1 point right there directly. And actually this point, even though it's a little bit off my line, that is hitting in that exact corner here. So I could mark all of these for my line. Again, you'll notice that my scatter plot, my points are all over. I'm not worried about those. I'm worried about the equation of the actual line that's been drawn. So then I realize that this is a negative slope. So I'm going to do my negative right from the beginning. And slope would be walking down 1 and over 1, 2, 3. So I have my slope. I have my y-intercept. I now write my equation. Y equals mx plus b. Now, you have to be able to do that in order to do the next part. So this should not be new to you. The part that's new is where we make that prediction. So step number 1, when I look at this, there's a couple of things I need to look at. First of all, ROC stands for rate of change. Instead of writing it out every time, I want you to find the rate of change, which is rise over run. So we're looking at what does the rate of change mean? Well, if you remember, our rate of change is rise, or my y values, over my run. So this is my y's are here. These are my x's. In other words, if it's my y's over my x's, my rate of change represents the elevation over minutes. So I'm going to write feet over minutes. That's what it represents. Feet over minutes. All of my x values are minutes. That's what all of my x values represent. All of my y values right here, all of these y values are my elevation. So I'm just going to write feet in elevation. Oh, whoops, feet. Now, this is what does my B or my y-intercept represent? So this is my y-intercept right here. This is where I'm starting. My graph starts at 900, but that's no longer just a number. What does that 900 actually represent? It represents that I start at 900 feet. That's where I'm starting, 900 feet. So now if I wrote my equation, I would have y equals my m here. I have a starting point right here, and I have another point right here. You are going to have to pay attention to your scale here. I did drop 1, but I actually dropped 100 feet. So right here where it says what is this representing? This is a drop of 100 feet every, and in this case, I'm counting by ones down here. So I have 1, 2, 3, 4, 5 seconds. So I'm dropping 100 feet, oh, not seconds, sorry, every minute. In other words, I drop 20 feet per minute, if you simplified this. So that's actually what my rate of change represents. In this case, it's saying I'm dropping 20 feet, and I'm walking down 20 feet every single minute. So my equation would be y equals, and you can leave it like this, it doesn't bother me, but I'm going to make it in simplest form, negative 20x, y equals mx plus, my starting point was 900. So writing your equation shouldn't be the problem. Understanding what all these means is where you sometimes struggle. That being said, what we need to do is figure out and predict the elevation of our hikers after 15 minutes. Well, my minutes were my x values. So that means we're going to be replacing that. So we would say y equals negative 20 times, we want 15 minutes here. So instead of it being x, I now know that x is 15 plus 900. Well, I need to solve for y. Y is already by itself. So that being said, I can just plug this whole thing into my calculator. So I'm going to do negative 20 times 15, and then I'm going to add on 900. What this tells me is that after 15 minutes, I would be at 600 feet. So if we were to write that as an ordered pair, it would look like this. Meaning 15 minutes, because that's my x value, 600 feet. So even though this 10 right here is at like 700 feet, again, I would be slowly going down, and when I got to 15 minutes, I'd be at 600 feet. All right, let's look at this next one. So it says, what is the rate of change and what does it mean? So again, these are my y's, these are my x's. Rate of change is y over x. The change in y's over the change in x. So this is telling me drinks, how many drinks are changing, and how many days it takes for them to change. So that being said, again, I'm going to find my rate of change. There's my starting point. There's 1 point. Here's another one. Again, you'll notice I didn't even pick any of these dots. It does not matter. We're looking at the line of best fit, not perfect fit, but best fit. So you'll notice it kind of splits my data in half. So I dropped down 1, and that 1 was 50. So I dropped down 50 drinks. That's what that represents. And that took 1, and we are counting in just days here. 1, 2, 3, 4 days. So really what this is saying, and you can leave it like this, but I'm going to change it to, we leave 12.5 drinks per day. Because that is what this is drinks over days. So they're selling on average about 12.5 drinks a day. So obviously they're not selling half a drink, but when they average it out, that's what it is. All of my X values are representing days. All of my Y values are representing drinks. Whoops, I didn't spell that right. Drinks. And then my y-intercept. My y-intercept is where this graph starts, where my line of best fit is crossing through on that y-axis. So this is 300 drinks to start with. Or we begin with 300 drinks, okay? Now my equation, y equals, I need my m. I'm going to use negative 12.5 for my m. You could put this fraction if you want, but when we put it in for an equation, it's just nice that it's not a big fraction. So negative 12.5, so y equals mx plus my b, I started with 300 drinks. There's my equation. Now I'm going to predict, and the reason we're predicting is because since this is a line of best fit, we're making a prediction off a line that's not perfect. That's why we're only predicting. So it says how many days until there are 50 drinks left. So my unknown, I have 50 drinks, and drinks represent my y value. That's what that represents. So I'm going to put in 50 here. I'm replacing y with 50, equals negative 12.5 x plus 300. I need to solve for x. So right now, this needs to be left alone. I'm going to subtract 300 from both sides. And now you're like, wait, but I got a negative. You're right. But I'm also going to be dividing by a negative here. So this tells me that if I had 50 drinks left, you're going to get, on this, you'll have x equals, and it will come out as 20. What that means is that in 20 days, there will only be 50 drinks left. So your goal on these, again, you have to understand what your x's mean, what your y's mean. You should be able to already write this equation. The only new part is plugging in whatever it says that we're looking for.